Hello, myself Sudipta Mandal, and you are welcome to my second class of dimensional analysis of subject fluid mechanics. Now, let's start. In last class of dimensional analysis, we already discussed about the fundamental fixed dimension, secondary quantity, dimensional homogeneity, dimensional analysis, and assumptions and its assumptions and procedures and also Rayleigh's method. But today we are discuss about Buckingham Pi theorem. This theorem is widely used in the dimensional analysis and it expressed the resulting equation in terms of pi, dimensionless term. In this method, n numbers of variables including independent and dependent, n numbers of variable including independent and dependent in a physical phenomena, and if these variables contains m number of fundamental dimension, contains of uh, m number of fundamental dimension, that is m, l and t, m, l, t, mass, length and time, then the variables are arranged into n minus m dimensionless term. Each term is called pi term. Let x1, x2, x3 xn are the variables involved in a physical problem, where x1 equals to dependent variable and others variables, that is x2, x3, x4 xn, are all independent variable. Then x1 is a function of x2, x3, x4 xn. Then we can write x1 equals to function of x2, x3, x4 xn. This is equation number 1, and we can write same equation in this form also. Now that is equation number 2. Now according to Buckingham Pi theorem, fundamental fixed dimension, that is MLT, fundamental fixed dimension are here represented by m equals to fundamental dimensions, and n is total number of dimensions, total number of variables. N equals to total number of variables, which involved in a physical problem. Okay, then in pi term we can write n minus m. So if we represent n minus m in as a pi term, then we can write f is a function, and pi 1, pi 2, pi 3, pi n minus m is a function. Okay, this is equation number 3. Now each of pi terms is dimensionless and is independent of the system. Okay, each pi terms is dimensionless and independent and independent of system. Number two is there are no any changes in the character of the pi term. There are no any changes in the character of the pi term. These also are assumptions. And number 3, each pi term contains m plus 1 variables. Each pi term contains m plus 1 variables. That this is pi 1 term, so it also contain m plus 1 variables. This is pi 2, it also contains m plus 1 variables. So in this point, each pi terms contains m plus 1 variables, where m equals to number of fundamental dimensions, and it is called the repeating variables. Now considering considering x12, x2, x3, x4, x5 are the are repeating variables. Okay, considering x2, x3, x4, x5 are the repeating variable. Now considering x1, x2, x3, x4, x5 are all variables in a problem where x2, x3, x4 are the repeating variables. Then fundamental dimensions m equals to 3, that is m equals to mlt, so it is 3 mlt. Then the pi term will be n minus m. N minus m, here n equals to 1 2 3 4 5, n equals to here n equals to here n equals to 5 and m equals to 3, so n minus m equals to 5 minus 3, that is 2. So there are two pi term, pi 1 and pi 2, and here we consider x2, x3, x4 are the repeating variables. So this x2, x3, x4 repeated in equation number 2, x2, x3, x4. So in pi 1 equals to x2 to the power a1, x3 to the power b1, and x4 to the power c1 into x1, and pi 2 x2 to the power a2, x3 to the power b2, x4 to the power c2 into x5. So x2, x3, x4, this term is repeating variables. Now we will discuss method of selecting repeating variables. Before discussing how to selecting the repeating variables, we have remember that the number of repeating variables is equals to number of fundamental dimensions. Okay, the total number of repeating variables is equals to number of fundamental dimensions. Then the choice of repeating variables governed by the following considerations. Okay, number one is as far as possible the dependent variable should not be selected as repeating variable. Number two, before discussing two, we are again focused on point number one. As far as possible, the dependent variables should not be selected as repeating variable. That means in a problem there are number of variables, and that variables, in that variables, one variables is dependent variables. So as far as possible that dependent variables should not be selected as a repeating variables. Okay, now discussing number two. In the time of the choosing repeating variables, that one variable contains geometric property. Okay, other variables contains flow property, and the third variables contain fluid property. This is very important. While choosing repeating variable, the first consideration is geometric property, then flow property, then fluid property. Now what is geometric property? That length, diameter, etc., these all are the geometric property. Length, diameter. Then flow property. What is flow property? Velocity, acceleration, these all the flow property. And which is fluid property? We all know viscosity, density, specific weight, these all the fluid property. And then number three, the repeating variable selected should not form a dimensionless group. The repeating variable should not selected from dimensionless group. And number 4 is the repeating variables together must have the same number of fundamental dimensions. And number 5 is no two repeating variables should have the same dimensions. Number 5 is no two repeating variables should have the same dimensions. This is very important, number 5. And so now we will do a problem. The resistance force R of a supersonic plane during flight can be considered as dependent on the length of aircraft L, velocity V, air viscosity mu, and air density rho, bulk modulus of air K. Express the functional relationship between variable and resistance force with the help of Buckingham-Pai theorem. Now, in step 1, we have to find out which variables are independent and which are dependent. In this problem, here the resistance force of supersonic plane during its flight time, the length of aircraft, that is L, V, mu, density and bulk modulus of air K. These all are independent because of these factors are affect the resistance force. So in this problem, R is dependent and out of all variables are independent. So at first, when we do a problem of Buckingham-Pai theorem, then we have to find out at first the functional relationship between independent and dependent variables. So in this case, the resistance force R depends on L, V, mu, rho and K. So this is equation number 1. So F1 of L, V, mu, rho, K equals to 0. This is equation number 2. Then we have to find out total number of variables in this problem. Total number of variables are R is a variable, length is a variable, V is a variable, mu is variable, rho is variable, and K also a variable. The total number of variable in this problem is 6. 1, 2, 3, 4, 5, 6. So total number of variable in this case 6. Now our object is to find out the dimensions of all variables. R, resistance force, it is nothing but force. So dimensions are is MLT inverse 2. Then L is a length, so it is L. V, LT inverse 1. Then mu, M, L inverse T inverse. Then rho, M, L inverse 3. K equals to M, L inverse T inverse 2. So these all the dimensions of these variables. So in this problem, the total number of fundamental dimensions is 3, that is M, L and T, M, L, T. So fundamental dimensions small m equals to 3. we have discussed about Buckingham Pi theorem, then at that time we are saying that m fundamental dimension is denoted by m in this case, in this Buckingham Pi theorem. So, and the definition, when we define Buckingham theorem, at that time we also discuss about n minus m, that is number of dimensionless pi term. Dimensionless pi term. Dimensionless pi term equals to that is n minus m. Here n equals to total number of variables and m equals to number of fundamental dimensions. So total number of dimensionless pi term will be 6 minus 3, that is 3. So hence from equation number 2 we also write pi 1, pi 2, pi 3. This is equation number 3. Now we will proceed in step 2. In this step 2, our main agenda is repeating variables, selection of repeating variables. Okay, so in step 2, each pi term contains m plus 1 variables. Okay, so where we know the m equals to 3, so each pi term contains m plus 1 variables. So each pi term contains m, that is 3, so 3 plus 1, each pi term in this case contains 4 variables. Okay, so this out of these 4 variable, 3 variables are repeating variables. So there are number of 6 number of total variables. Now we have to select which variables are considered as a repeating variable. So out of these 6 variables, that is r, l, v, mu, rho and k, 3 variables are to be selected as repeating variable. Okay, at first we are talking about r, resistance force. When we discussed about the selection of repeating variables, that time I also said to you that dependent variables are not selected for repeating variables. So r is not selected for repeating variables in this problem because of it is dependent variable. So we have now 5 variables. Out of these 5 variables, we have to find out the repeating variable. Now, out of remaining 5 variables should have geometric property, second variable should have flow property, and third one fluid property. So first consideration is geometric property, then flow property, and then fluid property. In this variable, first we are considered geometric property. So L is taken as for geometric property. So L is selected at first. Then second is flow property. Flow property means here velocity is flow property, so we are taking velocity V as a flow property. And last one is fluid property. Mu is considered as fluid property, rho is considered fluid property, but we are taking rho. So rho is our third repeating variable, which is from fluid property. Hence, three fundamental dimensions exist in L, V, rho, and they themselves do not form the dimensionless group. Now, we are in step 3. In this step 3, we have to form the equation of pi, that each pi term is written as according to the equation. Now first pi term is pi 1. First pi term is pi 1, then second term is pi 2, and third term is pi 3. We are talking about pi 1. Pi 1 equals to LV rho, that is a first repeating variable L, then second repeating variable that is from flow property V, and third repeating variable that is from fluid property, that is rho. So this LV rho is repeat all equation, so it is called repeating variable. These variables are repeated in all equation of pi, so it is called repeating variable. M plus 1, so in these 4 variables are there each equation. Okay, pi 1 equals to L power A1, then V power B1, and rho the power is C1, and one variable is R, which is dependent variable. The next equation is pi 2, L to the power A square A2, V to the power B2, and rho to the power C2, then mu. And third pi term is pi 3 equals to L to the power A3, V to the power B3, and rho to the power C3 into K. Now from third step we are proceed to fourth step. Each pi term is should by the principle of dimensional homogeneity. Okay, dimensional homogeneity. So we are considering first term, that is pi 1. We are considered that in this equation it is maintained the dimensional homogeneity. So the fundamental dimension is MLT. The power of m equals to the power of m here 0, then power of L 0, and the power of T is considered 0. That all the powers of m L T is considered here 0. Then we write the dimensions of these variables. We are considering this particular equation pi 1. Okay, so the dimension of L is L here. So then the dimension of V is LT inverse. We are putting the value of the dimension of V. Then we are putting the value of dimension of rho. Then we are putting the value of the dimension of R. Okay. Now we are considering in this equation the power of L is A1. Then power of V is considered B1 and power of rho is considered C1. So we are putting the powers of L A1, putting the power of V B1 and putting the power of rho C1. Now equating this, now equating the powers of MLT. Now we are equating the powers of MLT. That is in the we are considering power of M at first. At first we are considering power of M. So when we are considering power of M at first, in the left hand side the power of M is 0. The power of M is here 0. So we are putting here 0. Then here is no M, there is no M, but we are, see, there are M. So in the right hand side the power of M, here the power of M is C1. So we are putting the right hand side C1. Then we are found there again M, where the power of M is 1. Here the power of M is 1. So we can write 0 equals to C1 plus 1. From this equation we have to find out the value of C1. So the value of C1 becomes minus 1. Now we find the power of L. In this case, here the left hand side the power of L is 0. So we are putting the left hand side 0. Then here the power of L is A1. So we are putting A1. Then here the power of L is B1. So we are putting plus B1. Then here we are in this case the power of L is minus 3C1. So we are right here the minus C1. Then again here the power of L is only 1. So we write plus 1. So in this equation 0 equals to A1 plus B1 minus 3C1 plus 1. From this equation we derived, and the value of A1 becomes minus 2. Then after this we are find the power of T. So in this case the left hand side the power of T is 0. Then in the right side the power of T is minus B1. So here we can write minus B1. Then there are T. So here the power of T is minus 2. So we are right minus 2. So equation becomes 0 equals to minus B2 minus 2. So the value of the V2 equals to minus 2. Now we get the value of A1. Sorry, this is not B2, this is B1. So we already get the values of A1, B1 and C1. So now we are putting the values of A1, B1 and C1 in equation number in equation pi 1. In equation pi 1. Now we are putting the values of A1, B1 and C1 in equation of pi 1. So pi 1 equals to L to the power A1. We replace A1 by minus 2. We replace B1 with the value of B1 is minus 2, and we replace C1 by minus 1. So we are putting the value. So pi 1 equals to L to the power minus 2 into V to the power minus 2, then rho to the power minus 1 into R. From this equation we get the values of pi 1. Pi 1 equals to R by L square V square into rho. After first term, we are now in second term, that is pi 2. Pi 2 equals to mlt m to the power 0, L to the power 0, T to the power 0 equals to the powers of L, and this is the dimension of L, and this is the dimension of V, and this is the dimension of rho, and this is the dimension of mu. And putting the powers of L, V, mu here. So here also we applying the principle of dimensional homogeneity. So now here also we are separately find out the power of m, L and T. So in the left hand side of m, the power of m is 0. So here we are write down 0, then equals to, in the left hand side, right hand side, the power of m is only C2, only C2. Power of m is only C2. So we are write down here C2, then here the power of m is 1. So here we are right plus 1. So from this equation we get the values of C2 equals to minus 1, as it same as we are find the value of L and the we are find out the power of L, and we get the value of A2 minus 1, and then power of T. From the power of T we get the value of B2, that is minus 1. So from this equation we get the values of C2, that is minus 1, A2, that is minus 1, and B2, that is also minus 1. Now this putting the values of A2, B2 and C2 in equation of pi 2. So this is the equation of pi 2. Now we are putting the values of A2, B2, C2. The value of A2 is minus 1, we are putting here minus 1. Then the value of B2 is minus 1, and the C2 is minus 1. So we are putting here all the values of A1, B1 and C1. And after that we get the values of pi 2, that is mu by L, V, rho. Now same is happen in third term also. Here also we find out the powers of m, L and T separately, and from that equations we get the value of A3, B3 and C3. A3, the value of A3 is 0, value of B3 is minus 2, and value of C3 is minus 1. Now putting these values in equation of pi 3. So we are putting the values of A3, that is 0. We are putting the value of B3, that is minus 2, and we are putting the value of C3, that is minus 1. From this equation the value of pi 3 we will get k by v square by rho, k by v square into rho. Then step 5 is the final step of this problem. In this step 5 we are putting the values of pi 1, pi 2 and pi 3 in equation number 2. So in equation number 2 we are putting the value of pi 1, that is r by rho L square V square, and the value of pi 2 is mu by L V rho, and the value of pi 3 is k by v square into rho. So we are putting the all values pi 1, pi 2, pi 3 in this equation number 2. And from this equation we also find the functional relationship between all these variable with R, that is resistance force. So finally R equals to rho L square V square into mu by L V rho into K y V square into rho. This is the functional relationship between all dependent between dependent variable R with all independent variables with the help of Buckingham pi theorem. Thank you. If you have any questions about this class, please call me or WhatsApp me, or you can mail also.